This is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 8-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to graph a quadratic function in standard form. All right. Now understand, in order to correctly graph a quadratic function, you need 5 anchor points. All right. So that means that you need 5 points in which you can draw your curve through it. Now, some of these anchor points can be really quickly gotten by just doing a reflection across the axis of symmetry, but there still is quite a bit of calculation we have to do. So let's go ahead and let's begin. Now, the first thing I usually do is I usually find my axis of symmetry and then use that to find my vertex. So remember, to find the axis of symmetry, I'm going to use the equation x equals negative b over 2a. All right, so if I go to my standard form, my a is 2, my b is 4, and my c is 3. So I have x equals negative 4 over 2 times 2. All right, so that negative 4 can fall out of parentheses. 2 times 2 is 4. So my axis of symmetry is occurring at the line x equals negative 1. All right, which is right back here. Now, whenever I put something on a graph, I always try to label it if possible, especially when it comes to graphing quadratics, just because there's so much going on these graphs that it's really important to have, kind of a clear understanding of where points are. So now the vertex, remember the vertex of the parabola lies on the axis of symmetry. So I know the x value of my vertex is negative 1. So in order to find the rest of my vertex, to find the y value, I'm going to take that negative 1 and plug it into the function. So everywhere that there is an x, I'm putting a negative 1. All right, so on this first term, negative 1 squared is a positive 1, times 2 is 2. For the second term, 4 times negative 1 is negative 4. Don't forget that plus 3 comes down. So 2 minus 4 is negative 2, plus 3 is a positive 1. So my vertex is at negative 1, 1, which is right here. Now remember, from here, everything else is going to kind of just fall into place. All right? The next thing that I tend to do is I tend to locate my y-intercept, which remember is the point in which our x value is 0. So if I plugged zeros into those functions, the only value that's left would be that constant, the c. And so our y-intercept kind of just throws itself at you in the standard form, which is nice. And because this graph is symmetrical across the axis of symmetry, I could take this y-intercept and reflect it and get a third anchor point here at negative 2, 3. All right, so remember, we want 5 anchor points, and right now we're chilling at 3 of them. So I need to go ahead and find another one. Now, it doesn't really matter what x value you choose for your anchor point. You could just pick whatever, floats your boat. I usually try to keep the numbers small and easy. So like 1, 0, negative 1. Sometimes I go so far as to go for 2, but usually not really because I'm kind of lazy. But just whatever values are going to keep things nice and small if I can. All right. So in this case, I've already used negative 1 at my vertex. I've already used 0 because that's our y-intercept. So I'm going to go ahead and use positive 1. All right. Like I said, it doesn't really matter which one you choose, just so long as you get that point. Alrighty, so I'm plugging in 1. So here I've done that part. So 1 squared is 1, times 2 is 2. 4 times 1 is 4. Don't forget that plus 3 comes down. And so when I plug in 1, 2 plus 4 plus 3 gives me 9. So my anchor point is at 1, 9, which is right up here. And then I can reflect it across to get my second value, right? So this one is at -3, 9. And so now I have my 5 anchor points, and I can go ahead and draw my parabola in there. Now remember, these parabolas are like a U shape, right? They're a curve. So you might have some very narrow parabolas on your graph. Still try to make it a U, all right? So notice there's a lot of calculations I did on this. So make sure that you're very clear about your labeling so that people know what you're calculating, right? Because math is about communication, and if you're not communicating very clearly, you could confuse a lot of people. Okay, so let's go ahead and let's go through the try it together. So the first thing that we did, right, was we started by finding our axis of symmetry. That's some kind of x equals equation, right? And so for my axis of symmetry, it's x equals -b over 2a. So I have x equals -2 over 2 times 1. Because your a here is a 1, b is 2, b is 2, and c is 4. So if I go ahead and I get rid of these parentheses, 2 times 1 is 2, and -2 divided by 2 is -1. So this is another quadratic that has an axis of symmetry at x equals -1. Alrighty? So once we have our axis of symmetry, then we use it to find the vertex. Because the vertex lies on the axis of symmetry, and that tells you what your x value is there. So for my vertex, I'm finding the function evaluated at -1. So here I have -1 squared plus 2 times -1 plus 4. So -1 squared is a positive 1. 2 times -1 is -2. And so if I gather all these like terms together, I end up with a positive 3. So my vertex is at this point, -1, 3. Alright, now the next thing that we look for is the y-intercept. And remember, the y-intercept is the point that lies on the y-axis at C. So since my C is 4, my y-intercept will be here at the point 0, 4. And I can reflect that across my axis of symmetry to get a third anchor point. Alright, and then I just need to pick a value and plug it in to get my last set of anchor points. So the value I'm going to choose, I'm going to pick the number 1 and plug it in, just because 1 is an easy number. Alright, so when I do that, 1 squared is 1, 2 times 1 is 2, and the 4 comes down. So at 1, my function has a y value of 7. So there's 1, 7. And so I'm going to go ahead and reflect that across my axis of symmetry, which puts it at -3, 7. And now I have my 5 anchor points, and I can go ahead and draw my kind of U shape. Now I think that when Savvas does this, like particularly, I think Savvas only uses 3 anchor points, which is like the official number of anchor points, but I think that it makes your graph very difficult to read. That's why I do the 5. Alrighty, so starting out to find my axis of symmetry. Now this one's interesting because our A value is a decimal. But don't let that freak you out, okay? So up top I have a -3. Down below, 2 times negative 0.75 is negative 1.5. And -3 divided by negative 1.5 is a 2. So this actually is kind of nice because it gives us a very clean number for our axis of symmetry. It gives us this x equals 2. Alright, now our vertex, remember, lies on the axis of symmetry. So I'm going to plug in a 2 into the function, and that'll find my vertex for me. I forgot to label my calculation for the axis. Sorry guys. There we go. So again, I'm finding f of 2 to find my vertex. So I have negative 0.75 times 2 squared plus 3 times 2 minus 4. So 2 squared is 4. So negative 0.75 times 4 is negative 3. 3 times 2 is 6. And that minus 4 comes down. And so when I collect those like terms together, I get a -1 for my y value. Alright, so here we are. I have drawn my vertex in at 2, -1. So now I'm going to go ahead and use my y-intercept to get another point on here. And that y-intercept is my c value at -4. 1, 2, 3, 4. And I can reflect that to get another anchor point, so that's at 4, -4. Now I want to show you guys a trick. Do you see how the axis of symmetry is 2 away from the y-axis instead of 1? Like this one, they were only 1 apart. And on the first one, they were only 1 apart. But this one, we're a different number other than 1 away from the axis. So what that's going to do is that's going to allow me to use an anchor point using my A value. So watch this. I'm going to go 1 unit to the side of my vertex. So I'm going to go just to 1 instead of 2. And what that A value does is it tells us when I go 1 unit to the side how much up or down the quadratic graph goes. So 1 unit to the side, this parabola is going to go down by 0.75 units. So I go 1 to the side and down 0.75 units. It's about right there. And so that ordered pair is at 1, -1.75. So I don't really have to do any arithmetic for that anchor point, and that's kind of nice. And then I reflected it across the axis of symmetry, and I could go ahead and draw my little U shape. So again, that trick using my A value only works when the axis of symmetry is more than or less than 1 unit away from the y-axis, because the A value deals with only 1 unit to the side. Alright? So there we have it, guys. That is a few examples on graphing a quadratic function in standard form. Until next time.